This video is sponsored by PCBWAY, more on them later. Okay, we're back for round 2 with this thing. We'll try to fix the keyboard again. I also have another mod I want to do. These things, I got them from Detlef on the electronics channel. We did a live show last Sunday and he had some lying around, so he gave me some. We noticed that one of them probably has a fractured capacitor, so I have to check these on the microscope. We'll also check the ripple on these. Ripple is because this is a switch mode power supply and it's a direct replacement for a 7805 voltage regulator. This produces a lot less heat because it's a 90 something percent efficiency. So these produce a lot less heat, but they produce a ripple voltage. So the voltage goes up and down, and there is a small jaggy corners. So this uses switch mode. It has an inductor. You can smooth out the ripple putting a big capacitor in between the this one and this one. This is the output, this is the input, and this is ground. This is pin compatible with the 7805. Okay, let's get to it. Let's open this again. So I have an idea on how to fix the ribbon, making it shorter. Someone posted a link to one of Adrian's digital basement videos on this, and he fixed it as well. His backing wasn't as bad as mine, but it was still broken on the thick ribbon, not the thin one like mine. Okay, let's try this out. Trusty toolkit. We can also discuss what I am planning for this thing. So I have designed a few boards for this. Both of them connect to the expansion port, and one of them is a RGB output, so it takes Y, U and V out and converts it to RGB. The problem is, I've heard this connector here has the right outputs, but it's noisy. So I have to make a prototype first to see the signals coming out, check the lines near it to see what is introducing noise into that line, see if we can mitigate it somehow. It should be possible. Otherwise you can take wires directly from the ULA chip inside, and that way you skip the noisy lines, and that works. You get a nice picture, but I would prefer not modifying lines directly with soldered wires and stuff. I want a plug-and-play solution. And I also designed a prototype, let's say ROM cart. So this will interface with an ESP32 on the back here as well. This is the first revision, so I'm just making a cartridge with pin headers, so I can use jumper wires to a ESP32 just to make sure I can do this. This is just a prototype stage, so but that will allow me to make a ROM card with SD support and Wi-Fi and everything else. And the ESP32s are really inexpensive. So okay, so let's see. Let's lift this off carefully. Okay, I'm lifting off the big one first because that's not broken yet. And the small one. Okay. So where I left off last time, I put a bunch of tape to make this thicker so this doesn't break. And I left one corner uncovered. Or I should have left one corner uncovered. I'm not quite sure now. That's why it doesn't work. Okay, so let's test. Let's test first because I can't remember what I did. I did some trial and error off camera as well. Let's see, beep mode. Okay, so let's see from here to here. Okay, so I didn't cover this. So I'm going to put some tape on this side as well, just to cover this, but it seems to be fine all the way from here. Let's check all the lines. So the only place it can be broken is inside here. We'll look into that if needed. So this can actually be plugged in to the board as is, but it needs a firmer backing so it presses against the contacts. I use some contact cleaner as well here. I have some here, and I'll test that out. The composite mod worked really well on the TV. My upscaler didn't work as well with it. It didn't like it at all. It gave a really noisy picture, so you can actually set up the picture with these trim pots. I don't have the manual in front of me, but if you have an oscilloscope, which I do, I can actually test it out. I have borrowed a big analog one. I'll post a picture up here from Richard, and I also borrowed a small analog, digital one that's a lot cheaper, but it's usually the analog ones are better in resolution, let's say, and the new digital ones are more compact. So this is what I borrowed from Richard, the little one. 110 megahertz, that's more than enough. It's a nice unit. It's a Finritz branded one. I don't know exact model, but we'll find out in a moment. It also comes with a probe and a little other stuff. Let's see. Manual. Oh yeah, Finritz 1C15. So this is just one channel. So this won't be useful to me for the RGB stuff, because I need to check both the raw channel and the noisy channel to actually determine where the noise is coming from. But this is good enough to test video signals and other stuff, and the ripple on the regulators as well. Okay, so let's go for this. Let's put some tape on this side because the backing came off last time. This is going to be a lot shorter than it was at the beginning, but that doesn't matter as long as it makes contact. Okay, let's remove this. Let's get our trusty tape back. I found alternative scissors instead of these monsters. So let's try and pick another piece of tape. It's been sandy here, so I won't be trying to fix the connector like I did last time. Okay, so how deep does that go there? So this just helps to prevent this rubbing off, pretty much. It had a backing. This one has a backing too, but it's delaminated, as you can see here. Okay, let's straighten the tape layers up a bit. Sorry if my head is in the way. Can't really help that. This is not necessary, it's just for aesthetics pretty much, except for the tip. The tip actually needs to be somewhat tight because otherwise it doesn't go in straight. Let's turn this around so I can reach better. I am trying to follow the line from the old protector or the backing. These scissors are from sewing kit. Okay, so this should have, yep, I can see it not being shiny. I need something to stiffen the back part like this. This has a card piece, really stiff. So what do I have on hand that could do that? Let's see. Did I save the pieces from the... Yes, I did. Here is the backing that came with it. I wonder, is this stiff enough to use as a backing for here? On this side, of course. Not really. This is soft. Could put a lot of layers of tape, I guess. That should work. Let's try that. I don't have acetate paper or the transparency paper that usually people recommend for these kinds of things. This should stiffen it up quite a bit if I put enough layers. I'm trying to put them to one side so I don't need to cut both sides. If I can reduce my work in half, why not? Straighten wrinkles out. Ah, crap. Okay, so it broke again. Broke from here this time. So I don't have a choice. Let's open it up right here. These things are so flimsy. Okay, so how to remove this? You need hot air or a blow dryer or something like that, and you need to start lifting a corner, and it has double-sided adhesive. You can see here I have my fingernail underneath. You can put in some alcohol, that usually helps with loosening the adhesive as well. I have double-sided tape at home, so I don't mind taking this off. And I'll probably get a new keyboard membrane anyway, even if I manage to get this working. Okay, that worked. Better than expected. This is aluminium, so be careful when you're ripping it off. Because if you deform it and bend it, you're pretty much stuck with that. Okay, so it doesn't want to get loose on that side. Okay, that worked pretty well, I would say. Let's see if we can actually fix this anyways. But from a rip like that, it's probably not fixable anymore. Could put pressure on two sides to make it stick, I guess. Minimal damage. Let's remove the membrane, check how dirty this is. You can see the double-sided tape right here. I'm going to be removing this. Sorry, there we go, glare. This is really crunchy and old. Just scrub it off. That should be fine. This looks good. I don't want to remove the laser, so I'll be really careful with this. This looks okay. It's a dirty, some crap all around, but decent, still decent. So this is how it works. It has multiple layers. It has some crap inside, so could be that it didn't work to begin with. Some residue on the tape. Alcohol seems to be make it get loose from the plastic, so that's nice. Brush. Okay, no, it has to be some friction. So fingers. I'm getting ahead of myself. Okay, so okay, that's why this breaks so easily. So in the newer versions of this, they have a pressure plate that squeezes it. This one does not. Okay, so let's try to bring out the membrane. Has a couple of posts. There we go. The case itself seems fine. So let's put that to the side. Okay, so let's check the membrane. So it broke directly from here. Pretty much impossible to fix. This one is on the way out as well because of the bend right there, and the backing should help prevent that, but if it gets a little rip, it usually just goes straight off. I'll see if I can fix the glare, but this is made in multiple layers. So let's get some paper and clean it off and see if we can do anything with this. Is this the conductive side, or is this? This is the conductive side. So this is sandwiched right here. So I could theoretically put in 4 wires and squeeze them together in between the layers and get some contacts. I think it's 4. 1, 2, 3, 4. This has more. This has 1, 2, 3, 4, 5. Where does the 5th one come from? Okay, so let's see. So this came off like this, or was it like this? Probably like this. Okay, let's see. 1, 2, 3, 4, 5. Oh, okay. I can't count. Guess that's the problem here. Okay. Can we fix this? Probably not. That's too bad. This is not going to make it to a video. I removed the tape we put on last time. Is this conductive on this side, or do we need to split the layers? Okay, the conductive side is up. So this side up. Okay. Is this fixable in your opinion? I don't think so. Not efficiently anyway. This would require a lot of fiddling around that I don't have time for. So this is scrap pretty much, because I was a little too forceful. Could be that it was broken already from before because it ripped so easily. But if we get a new keyboard, that should be fine. We can still test these on this video, so let's do that. At this point I was ready to give up. I checked online the usual sources, and these are expensive. It's about 20 euros to 50, and they're out of stock almost everywhere. So I thought I could do better with today's sponsor, PCBWAY. They currently have the Black Friday deals up for up to 50% off from the 23rd of November until the 30th. Don't miss out, these are great deals. There are a lot of coupons for different price ranges. Just make sure you go check it out. Now back to the video. Sneak peek of the PCB I designed. Now really back to the video. Hook this up first of all. I need a 9-volt power supply. We'll check the thermals and the ripple on this, and then we'll go over to changing this out. We can actually remove the entire heatsink, considering how little heat that pumps out. We don't need to screw it on to anything as well. Doesn't have bent pins like that one, but should be able to bend them in place. or desolder them and solder them straight down. That should also work. I have more pin headers like these, so that's fine. So what I was thinking, this is in, this is out, and the middle is ground. This is in, this is out, and the middle is ground here. So it goes like this. Does it have anything that can short out on the backside? Not really. It's not even marked on what voltage it is, but you can actually change it, changing the capacitor right there. Or those two small ones right there. So let's see if we can see that. It has two small caps on the side. Okay, so let's start by measuring this. It uses center negative. So let's see. Center negative is the Mega Drive one. It has the same plug as the Mega Drive. My Mega Drive one is center negative. Okay. I think it's a 1.75 millimeter one. Oh yeah, there we go. Flies everywhere. Okay, so it's buzzing. Just turned on. Thermal camera. So it has a little too much heat from the ULA chip and the voltage regulator. So let's see. Can you see that? So that's the voltage regulator right there. It's producing about 30-40 watts or Celsius. Sorry, tired. And the ULA chip is overheating right here. It's really warm at 60 or 70 degrees sometimes. There is also a hotspot right here, but could be this converter chip. This converts from the YUV to composite, and then from composite to RF right there. I don't see any other heat sources. There is one right there. That's actually the metal heatsink. Okay, let's go over to and modify this. Oh yeah, let's test the ripple first before we mod it. So I won't be using the analog scope for this because this should show it quite good as well. Let's see. It should be battery powered, so I don't know if it's charged or not, so let's check, take a look. So for those who don't know what oscilloscope is, it pretty much shows the waveform of the digital information, but you can use it to measure analog voltages as well, from peak to peak and stuff like that. Okay, so it has a B and C connector. Put it in with the opening, notch in, spin, and locks. Let's start it up. On off somewhere. Okay, I don't see an off. Menu. Okay. Has a small joystick in the middle. Don't see an on-off button. Oh yeah, here it is, on the bottom. Seems it doesn't have any batteries, but yes, it does. Okay, so how you use these things? You have a 1x and 10x. You have to have the same one set on the scope, or on the scope, yes, to get the right picture. let's do this. It's receiving something, some RF disturbance. It has one of those small hooks. Let's see if we can see that better somewhere. There, a small hook, and it has the ground clamp. So this is ground. So let's clamp it right there, so that we have the closest ground point. And we can remove this that has the small hook and just use the point. So it's super noisy, the 5 volts. That's why it's making noise. The 9 volts coming in. We can step into it to see the actual sawtooth. So let's do that. We have 5 milliseconds per division, AC at 10x. That's what we have set here. So let's see if I can remember how to do this. Millivolts per division. Every small cube in the display is 200 millivolts. So let's speed this up. Let's see. We can put a trigger as well, so it stops and takes a picture. Let's put it on auto and see if it can figure out what I want to do. So 500 hertz or so. God damn it, there. Okay, 500 hertz at peak to peak 460 millivolts. So it has about half a volt of ripple. That's a lot actually. Duty cycle, and it should show the voltage, but it doesn't. Voltage 500 millivolts. Okay, so this changes the, so it's not really showing the voltage. It should show how many volts by jumping up, but it's not moving. This is 9, 1 volt per division, so it's not on. Yes, it is. So I'm conducting more electricity than the actual. Give me a sec, I'll figure out how it works first of all. Okay, volts. 200 millivolts per division is the minimum you can have. At 10x. Should we put it at 1x? 20 millivolts per division. Okay, let's see. I change it to 1x, if that works. I'm not very good with oscilloscopes. I haven't used the one in a really long time. So could be my issue here, pretty much. I can't really see the screen, so let's do this. Okay, now I can see it, but you can't see it that well. I'll show you if I find something interesting. Peak to peak 152. So let's go up 100 millivolts per division.
Look.
Yeah, babies.
I'm trying chicle.
I'm
trying this, look.
Yes, babies.
I'm trying chicle, Papa.
Yes.
Bubblegum.
Okay.
Mama put the, I eat the bubble gum, chup chup, and then Mama eat one too, and then you blend it to show how make a bubble out of chocolate.
Oh, I have it on AC coupling. Sorry, my bad. Well. Let's go back to 10x. One volt per division. That's outside.
Mama,
Half a volt per division.
but don't start the chocolate. Don't make a bubble yet.
2 volts per division. So 2.5. Okay, perfect. This works now. Or rather, I figured out how to make it work. Okay. So hopefully you can see what I'm doing right here. So I have it set, so for newbies with oscilloscope as well, to 10x, 2 volts per division. So right here you can set the voltage per division. You have 2 volts on the screen right there. It's a little unclear. I have DC selected. That's what the problem was before. I was using AC. You can change it right here. This goes down, this goes up in the voltage. You have also a trigger if you need that, but that's fine. Okay, so oscilloscope. The middle is 0 normally, and every one of these, because of the setting, is 2 volts. So it should end up in the 2 up and a half to get 5 volts. So let's try that. And that's mostly what we get. Okay, let's see if I can get a better. Okay, so the important part here is the, let's see if I can point at the same time, the peak to peak difference. So 320 millivolts of peak to peak noise, pretty much. So the thing is, we have to watch out is with the new regulators, these ones. It has to be equal or less, but most probably it will be more, but we don't know if that will disturb the system. This is getting awfully hot. Let's bring out the thermal camera again. Okay, so now we know 320 peak to peak.
Show me what it's chocolate to make a bubble.
Move them back again to the flare. Let's put on the crosshair. So the regulator is about 70 degrees now. 60 degrees. Yeah, 60 C. I don't think you can see the temperature reading.
This is chocolate.
Says 62. The ULA chip is, I'll tell you, 92. So we need to fix that immediately. So let's turn it off. The ULA chip can't be fixed this way with replacing it, or maybe it can, but from my point of view, you just put up a few heat sinks and it should be enough. I think I have some lying around. I just have to dig them out. Let's just go out here a bit. Okay, time for some desoldering. we need to remove the screw first of all. So it's a flat head. This have live power, so we don't want it touching. And I think I need to remove the board as well, so let's remove the screw first. That tricked me the last time. Let's put the screws on the magnetic holder here, so I don't lose them. And this is a flat head, biggest one I got, probably. This is the biggest one that comes with the kit, should be enough. I don't think this cools anything else, so this can be removed completely if this doesn't heat up. So the reason this heats up, it takes 9 volts from the barrel jack, goes into the regulator through various other stuff, and then steps it down, the voltage. The problem is it dumps all the voltage that's over the normal, let's say 5 volts that it's going to output, and dumps it as heat in this. The ULA on the other hand is just badly built, pretty much. Okay, so let's see. It's doing a lot of stuff, so we can excuse it for that. Okay, so let's remove the board and let's start taking that out. The screw had a nut underneath, this one. Do I have anything conductive underneath? No, not really. Okay. Okay, so desolder these 3 right there. Let's put them in the middle. So my experience is using a soldering iron with a lot of flux and what's the other thing called? Solder. Should fix this. So you just want to flood it with new solder, because lead-free solder that comes from the factory is a lot harder to dissolve or melt or whatever you want to call it. Okay, so let's see, soldering station. I let that heat up. My homemade paste or liquid flux. That's not liquid anymore. Looks like some other random white liquid. Okay. Let's rip off a piece of this. I usually do this because I have the thin stuff, 0.3 millimeter. I don't have the thick. I have ordered some, but it takes a while to get there. So what I do, I double it up and spin it around, so it fills faster, pretty much. So I have the iron set at 350. Not really warm enough yet. Let's clean off the tip. There we go. Get heat into the joints. It smells really bad, like all electronics from this area. Okay. So let's see if I can work this out. It's coming. Just taking a while longer. So you don't want to put too much heat on the pads, obviously, because this is old solder mask. You can use a vacuum pump. You can use a lot of stuff actually to make this work. Okay, let's prop this up so I can pull while desoldering. Let's get this, because I'm using it left-handed, so sorry if I suck this. Try to get all three at the same time or get one out. There we go, it's out. What I know, there's no damage pads either. So I just have to clean off the holes. Let's do it from that side. Put on some more solder on the holes so I can suck it up with the braid. Some flux. Some braid. Like I said the last time, if you have cheap braid, don't leave it like this. Spread it out. So push down on it like this and just spread it a bit. That will help with surface area and will suck in more solder like this. And you want some flux inside the braid as well. So what I do is usually take the piece of braid I'm going to use, dip it inside my flux like this. That makes all the difference, by the way. So let's go. Hold the braid. These are thick power plane tracks, so these will take a bit of time to clear out. Just take your time and try multiple times if you need to. Let's get a closer shot of this. Okay, so you can see this clearer now. Middle hole is pretty much clear. Sometimes it helps to put more heat into the joint. There we go, that hole is cleared out. Next one. Didn't help. So sometimes the braid sucks up a lot of heat up. So the easiest way to get around that is just to cut off a piece. Snips. My snips are really bad. They're completely destroyed, but new ones are on the way. So what you do, yeah, I'm not even cutting the braid anymore. Look at this. There we go. So how you hold this instead? You hold it with some tweezers. Okay, so let's try this again.
Look at this. Look at this button.
Yeah, Papa.
Oh yeah, I got another button.
Yeah, Papa recording this. It's taking a little more heat than expected, but that's usually the case. So the second hole is also done, so it's just the third one. It's not wanting to clear up, so what you do then, this happens a lot with cheap stuff. more solder, same thing again. The more flux really shouldn't be necessary, but okay, so I'm not transferring any heat. So this trace is a little thicker, so it could be that, or my soldering iron sucks. So it's a little bit of both. So I'm not transferring enough heat. That's why I'm not getting that off. So I'm going to go up to 400, which is not 400 really, because these cheap Chinese irons don't really do what they say. Okay. So I need to transfer more heat into the braid, and some flux will always help. You can always try from the other side as well. Okay. Hole is still not clear.
This material I'm always in my blanket.
Got some stubborn solder right there. So what you do in this case, you see it looks like it's through, but it's not. You can't see my finger underneath. You can't see it on the other hole. So I'm not worried about this one. So it does melt, but I can't get enough heat into the joint. So let's mix more solder into this, go to the other side, do the same. Okay, and now let's try this again. More flux. Sorry if I'm not in frame. Let's see if I can get you a better picture. There we go. Okay, let's try this again. What you can do is change the tip on your soldering iron. I use the curved tip, but in some cases that's not enough for heat transfer. Well, I think I'll have to change the tip. Let's go for 450, no, 480. That's the max of this iron. Doesn't really want to work. So this is max temperature, 480. Dunk it in some flux. And hopefully this time it will suck up all the solder. It does not. So this happens with all the electronics a lot. Solder is just annoying to get off, but just keep at it, you will eventually get there. Try not to rip a pad, that's the only thing you should be careful with. Okay, so let's see if I can get heat into the pad. Okay, I'm forced to use the solder sucker. I hate these things because you never get enough heat to use these. Can't get enough heat into the joint from that side. It's taking out something, but okay, time for some drastic measures. Solder sucker from underneath, while I heat up from the top, pretty much. Okay, let's see if we can get this propped up. Or heat up from the bottom and suck from the top. Let's see if I can get this to work. Okay, so let's try from the top first. Oh, I made it a slight angle. Did that work? Did something. I think I need something to heat up. Okay. So it's counterintuitive. You need to heat up the joint with more solder just to be able to suck out the solder. Okay, I'll do it off camera. There we go. Okay, got it. So all three holes are clear. The way I did it was put it on the table on angle and put the sucker underneath and warm up the joint from the top. Okay. Time to check these. one of them had a fractured capacitor. Yeah, this one. Can you see the small line there? That looks like a crack in the capacitor, so we'll not be using that one. Let's see. Yeah, this one doesn't show the. Yeah, it has a small one there as well. Let's go to the next one. This one doesn't have anything, so let's go for it. Okay, so because I want to orientate it like this, actually the smartest thing for me to do is remove the pin header, just desolder it, and solder a new one that's just points straight down, because I want it lying down like this. Because the original one was bent, the pins were bent back. Let's see if I can find the original one here. See? But this doesn't have long enough feet, I'm guessing. Well, could actually work. But this is all metal, I don't want it touching, so it's better to put some solder joints and a connector on it, on the bottom side instead. So let's do that. Okay. So to remove this, same, a little bit of solder and some flux, and this should just drop off. You can also use the a wick, just to wick it out, the excess solder. Okay, let's go. Let's get some leverage going. Oh. Okay, so let's turn this on. I'm using the thick tip again. Let's see if I need new solder or not. Still not warm enough. Pre-tin your iron. There we go. No. It should drop out immediately, but yes, comma. Vänta en minut. Should just drop out, but it doesn't. Unlucky me. Surface tension, yeah. So what you need then is a pair of helping hands, so you can pull while you're holding it instead. Like this. Heat up. One is out. There we go. It's out. Now to clean off the holes. Okay. That's annoying. The entire bar is moving. Okay. Vad händer? Okay. Wait a minute. Okay, let's do the solder sucker. Worked. Let's see if it's cleared. Yeah, the holes are clear. Okay, we'll be right back. I'll be using some of these pin headers, single row. This one, you can buy them in bulk. I bought a lot of them. So break off 3 in a row. That's what we need. Like this. Should go into the holes quite comfortably because it's the same pitch as the ones that were on it originally. Just push up until they go through. You can see them right there. One of them didn't go through. You can see. So these aren't the best quality ones, obviously. Okay, so the hole was clear. It is clear, but it's not super clear. Okay. So if I can clear it out a little bit more. From this side. Sometimes it's just a small burr that's stuck. Okay, it went through. Cool. Okay, pins are back the way they were. I pushed them against the table, pretty much. Push them through again. Just make sure they're aligned. They are aligned now, and the 3 ones go through. So just put some solder on each of them. That should be fine. Turn on the soldering iron, reduce the heat quite a lot, 350. Flux, always be careful with the capacitor or resistor right there on the corner. There's a small resistor here. You can take that off really easily if you're not careful. There we go. I took some solder and I'm twisting it up as I wait for the iron to heat up. I should buy thicker solder, but I haven't had time. And of course it costs money to buy solder when you already have solder. Did the pins fall out? Yeah, they did. Okay, so time to remove the pins again. Or push them in while I heat up the solder. So what I did, I took them from underneath, let the tweezers press up, and put the soldering iron onto the side, melt it, wiggle it around, and push and let go. There we go. That's one. Nice joint, even. This one is in the way. So instead of making the piece comfortable, you can make yourself comfortable. Just spin it around as needed to get the best angle. I am right-handed, so I spun it around so it will be easier for me. That looks about right on this one. Too much solder, easily fixed. Nope, did I destroy them already? Oh, that looks good actually. So use a smaller tip for things like this, make your life easier. There we go. By the way, you heard maybe heard of shiny joints mean they're okay. Not in this case. This solder is quite crappy, so I'm never getting a shiny joint no matter what. So that looks good, and I can just plug it in that way, just straight down. Because there is no conductive pads on the bottom on this, there should not be a chance for a short. Let's clean this off with some IPA and a brush. I usually use a toothbrush, but I can't really seem to find the good one. This works as well. You can also use some paper. Do the same treatment for this side. Usually I use one layer like this and dab. That usually fixes it. This time there was a little more. That's good enough. I found a toothbrush, but it's really crappy. It's so crunchy. But it works. The reason it's crunchy is because it has a lot of IPA inside the bristles. Or flux. Let's see if we can fix it. It feels a lot smoother. No? Okay. There we go. Ready to install. Okay, so you put it in the way it came out, like this. The only thing I did was desolder the pins that came out this way, straight down. And because they made the pitch the same as a 7805, it should go straight in. It did. There's a small piece that comes out here. It's not straight. And let's straighten it out. There we go. It's really nice. We don't need the heatsink anymore because it doesn't generate any heat. And I don't think the heatsink was used as a grounding medium in between different layers. Could be. We'll see that in a second. It just touched right there. So this side. So this is pretty much useless now. Okay, so let's solder this on. So you do one side first. Put some flux on. So over here. So flux. A lot of it. Solder. And soldering iron, obviously. Don't forget to clean off your iron. It's good practice. That looks about right. Yep, that's nice. Just double check so it's flush on the side, right there. So I'll go for next one on the other side. That also looks decent. I'll need some more solder. This one is probably going to be the hardest one to solder. Most thermal mass. So that is soldered, but I would like a little bit more. Sorry, I have to inspect the joint from other side. Yeah, no, it needs a little bit more. There we go. It's done. And let's inspect our work. Ow, it's so hot. Decent joints, not wow, but decent. Okay, so let's clean this up. So we lost a little bit of the solder mask right here, in between and here, but that is fine still. Okay, so there is no connection in between, right? They don't seem to be touching. No, they're not. Okay, regulator in place. Looks decent, I would say. Okay, time for the test. So the way you know how it works is in, out. I had the 5 volts here, 9 volts here, and this is ground, so that's perfect. That's why this trace was really hard to fix or to clean out. Usually ground connections are extremely thick. Okay, so let's put it in the case. Not that this is needed, obviously, but I want to see it if it fits or not. That seems about right. Okay, no heatsink. Let's try that. I'm hooking up the -5 or 9 volts. It is making noise. I'm not sure what it is. This one probably. A small chirping noise. Okay, let's check the voltages. Okay. Volts DC. I should choose 60 maybe, because I'm going to measure 5 volts as well, and 9. So we should have 5 here. 4.93. That's not too bad. And 9 over here. Yeah. Okay, perfect. So we have the voltages we need. Let's check the ripple. That's the thing that's actually worrying me. If the ripple is too high, it can interfere with the electronics inside the machine, and then it won't work anyway, even if it has the correct voltages. Okay, so I don't have a good ground point anymore. Yeah, that's probably the good the ground plane's good function. Let's see if we can figure out what else is ground here. Okay, I can put this on the 5 volt leg here. And put the ground there. Nope, not working. Okay, I'm not getting a good connection with this. Okay. Let's try to show this. Okay, that's decent picture. I'll remove Okay, let's use the hook. Hook doesn't work for me. So I'll hold the ground with my hand. This could actually introduce more variables, but for now. There, we have 5 volts. It's 2 volts per division, so 2.5 makes 5. And it's 320 millivolts peak to peak noise. That's insanely good, actually. And goes down to 200 and up to 400, so it depends on the duty cycle, I guess. Okay, so that means this should be actually working. It's the same peak to peak noise it had before. This should not get that hot anymore. Time to confirm my camera. I'm using all my tools today, and some I borrowed. Ignore the shift in components. The camera overlays the components. So this is the regulator board. 40 degrees. Still getting somewhat hot, but not even close to what it was before. Before it was 60 or 70 degrees. The ULA is still quite hot. It's about 85 over here. Let's see if I can show you over there. So 83, 84. So that one needs a couple of heat sinks. So let's see if I can find some. Okay. These ones. Unfortunately, I don't know if the glue is okay. They're stuck together. Let's try to separate them. I turned the machine off, by the way. So don't get your panties in a bunch. There we go. Seems to be fine, the adhesive. Let's clean off the ULA with some alcohol. So it gets hot right about here. Let's see if I can put 2 of these. Okay, they stick. They don't move really. They're not that tall. They're actually lower than the RF modulator, so that should be fine. And this should dissipate enough heat. So let's plug it in again and check. This is really handy to have the from a camera on the phone. Okay, let's see if I can find the ULA chip. Yeah, look, the heat sinks are barely getting warm. Let's see if we can get the side. The chip is not getting warm there anymore, and the hottest point is 50-ish degrees, which is a huge improvement from. Okay, so let's see if I can show you on the camera. There we go. So these are the heat sinks. You can see them here. They're not even hot yet. Then the hottest point on this thing now is about 50 degrees, 60. But the improvement is from 80 to 90 degrees, so that's really good. The hottest point is actually around here. Huh. What's that? That's a resistor in line with the ULA. This one. Oh yeah, it's kind of toasty. Interesting. Okay, so that should do it for this video. We'll show this working now with the modifications, the heat sinks, and the voltage regulator. Unfortunately, without the keyboard, I can't really test it out. But we'll get a new membrane and keep going from there. We'll also be making the cartridges that go to these slots right here. This is the expansion slot. It has two sides to it. See, and they're different. They're data lines on one side, and the video signal actually comes out there as well. This is the ULA, and this actually outputs the YUV video to that connector over here in some of the pins. I can't remember which ones right now on top of my head. And it actually sends the YUV signal to this chip right here, and this actually makes composite video from that signal and sends it over to RF, and then converts it to RF and sends it out to the TV. But we modified this last time to composite only, so it skips the box in and just sends the RF or composite directly to the RF output. So my idea is, instead of running wires, drilling holes, and putting RGB out here and sync, you can get sync from the composite. You can actually just bring it out from here. The problem is the signals right here instead of here are quite noisy. So one of the lines it goes near actually introduces noise. So if one of the carriers, one of the lines that carry data to the line there, is the culprit that introduces the noise, we can use that signal to nullify the noise in the YU and V connections that are here somewhere. Hopefully I'm making sense. Also, I'll make a ROM cartridge with a ESP32 interconnect, so we can make our own ROM cartridge with SD support and Wi-Fi, Bluetooth, whatever we want, pretty much. We'll see how that works, but I'm making a prototype cart just to do some testing and some initial programming. I'm not too familiar with Sinclairs or ESPs, so that's going to be an adventure. Hopefully you join me for that in our next upcoming videos. Those two videos I mentioned with the PCBs will be sponsored by PCBWAY in the near future. And they will be project, so there will be several versions of the projects as well. Okay, thank you for watching until the end. Hopefully you have a nice one. We'll see you next time. Bye bye.